Chemistry is the study of matter, and since hair is matter, every successful professional cosmetologist should understand chemistry. In this chapter, you will explore 3 areas of chemistry as they relate to cosmetology: matter, the pH scale, and the chemistry of cosmetics. But fear not, it's not nearly as complicated as my hairdo. Our first chemical topic is matter, which covers anything that occupies space.
All matter exists in 3 forms: solid, liquid, or gas. Hair is matter, shampoo is matter, oxygen is matter. Chemistry is the scientific study of the physical and chemical changes of matter. For example, when this tray of water freezes and changes to ice, that's a physical change. The ice is still water, but now it's a solid instead of a liquid. An example of a physical change in hair would be the temporary change that occurs when air forming or drying wet hair. An example of a chemical change occurs when hydrogen combines with oxygen to form a new substance, water. In hair, an example of a chemical change occurs when the hair is permanently altered into a new curl configuration through the use of processing solutions.
Whether liquid, gas, or solid, all matter is made up of chemical building blocks called elements.
There are over 100 known elements in the world. Hair is composed of 5 elements: carbon, oxygen, hydrogen, nitrogen, and sulfur. Just remember, cones: carbon, oxygen, hydrogen, nitrogen, and sulfur. And you've got the chemical symbols for all the elements that make up hair. All elements are composed of atoms. An atom is the smallest complete unit of any element, and it looks a lot like a solar system. Every atom has a nucleus, which is made up of protons and usually neutrons. Around the nucleus are orbiting electrons. The number of protons in one atom establishes its atomic number. Hydrogen, the simplest atomic structure, has 1 proton and 1 electron. When atoms combine chemically, they form molecules. A molecule is 2 or more atoms joined together by a chemical bond. Water is an example of 2 hydrogen atoms combining chemically with 1 oxygen atom. Hair is created with similar chemical bonds that eventually create the building blocks of the protein for hair. This happens through chemical bonds beginning with amino acids. Amino acids create all proteins. Every amino acid is composed of carbon, nitrogen, oxygen, and hydrogen atoms. Hair is a form of protein called keratin. Keratin in hair contains 19 of 22 common amino acids. Hair is made up of 97% keratin protein and 3% trace minerals. These amino acids join together in chains in a specific order and arrangement to become proteins. When 2 amino acids are positioned end to end, the acid end of one amino attaches to the amino end of another. The bond created is called the peptide bond, or end bond. As a stylist, you will be altering these links. You need to know how your tools, techniques, and the chemicals you will be applying will affect your client's hair. It's important for you as a stylist not to disturb the peptide bonds. For instance, combining alkaline chemicals and heat could break these critical peptide bonds and destroy the protein structure. The result? The protein chains separate into small fragments or revert to groups of different amino acids that no longer have the characteristics of hair. Next, let's take a real close-up look at the keratin protein of hair. Notice it has a spiraling configuration. These spiraling chains can be linked and held together by 4 side bonds. Each bond has its own characteristics and serves a different purpose in building hair. The bonds are the hydrogen bond, the salt bond, the disulfide bond, and van der Waals forces.
The use of chemicals in hair affects all these bonds. That's why it's important for you to understand how the 4 side bonds work.
The first bond, the hydrogen bond, works on the principle that unlike charges attract. Hydrogen bonding occurs when the hydrogen atom in one molecule is attracted to an atom of another molecule with many negative electrons. Hair has millions of hydrogen bonds in its structure. They are weak and easily broken down with heat or water. However, because of their numbers, they give hair its shape and provide about 35% of its strength. The salt bond is also a result of unlike charges attracting. Here, the negative charge in one amino acid grouping attracts the positive charge in another amino acid grouping. They also account for about 35% of hair's resistance to change. Because of the nature of salt and hydrogen bonds, hair can be shampooed, set in rollers, and reformed with any styling tool to create a new shape. That's because when the hair is saturated with water, the hydrogen and salt bonds are weakened, leaving the hair more pliable. However, it's only temporary. Exposure to water or even humidity can break the new bonds and restore the original ones.
And remember, styling hair with rollers, a blow dryer, or curling iron is a physical change.
The disulfide bond is formed when sulfur-type side chains join with other sulfur-type chains. Many chemical services, such as perming and relaxing, directly affect the disulfide bond by either breaking the disulfide bond or reforming it in a new shape. This process is a chemical change. And here's something you don't have to remember: the van der Waals forces bond. This bond is not important for your work as a stylist. Just remember it exists and does play a role in bonding protein chains. Let's take a minute to review. Hair, like all matter, is composed of individual atoms, the smallest unit of matter. These atoms unite by sharing electrons to become molecules of amino acids. There are 22 common amino acids. End or peptide bonds are formed when one end of an amino acid bonds to the opposite end of another amino acid. Amino acids link together to form protein chains. Hair is a form of protein called keratin. Side bonds link individual protein chains side to side. There are 4 types of side bonds: hydrogen bonds, disulfide bonds, salt bonds, and van der Waals forces. The bonding of protein chains to other protein chains makes human hair.
There's no doubt these ideas are difficult, so don't hesitate to ask for help. Your mentors and friends want you to be successful.
Refer to your textbook and study guide for more information on matter.
pH, that's a term you'll hear a lot of. It stands for potential hydrogen, and as a professional cosmetologist, you'll need to understand pH and its effects on hair, skin, and scalp.
It measures the amount of acid or alkali in water-based solutions. A solution is acidic or alkaline depending on the number of positive hydroxide ions or negative hydrogen ions. If a solution has more positive hydrogen ions, it is acidic. If a solution has more negative hydroxide ions, it is alkaline. When negative hydroxide and positive hydrogen ions are equal, the solution is said to be neutral. The pH measurement scale ranges from 0 to 14, with 7 being neutral. Numbers less than 7 indicate acid, and above 7 indicate alkaline. The scale is logarithmic, which means each step or number increases by multiples of 10. That makes a pH 6 10 times more acidic than a neutral 7. And it makes pH 14 10 million more times alkaline than 7. So you can see a slight variation in the pH factor of any salon product greatly affects its acidity. The terms pH balanced and acid balanced are often confused in the industry. pH balanced means the pH is balanced at a certain number, but not necessarily at 4.5 to 5.5, which is the average pH range of hair, skin, and scalp. Acid balanced means it is balanced within the acid range of 4.5 to 5.5. Acid balanced products are generally preferred in the salon.
Remember, one of the keys to help you understand complex material is to summarize what you are learning in your own words.
Refer to your textbook and study guide for more information on the pH scale.
Now let's look at the chemistry that's directly related to cosmetics.
Cosmetics were defined by the Food and Drug Act of 1938 as articles intended to be rubbed, poured, sprinkled, or otherwise applied to the human body or any part thereof for cleansing, beautifying, promoting attractiveness, or altering the appearance. Cosmetics fall into 6 general classifications, which are solutions, suspensions, emulsions, ointments, soaps, and powders. Knowledge of these classifications will help you understand product labels and directed use. Solutions are mixtures of 2 or more kinds of molecules evenly dispersed, like instant soup and hot water. In this case, water is the solvent. The soup is called the solution. Suspensions also mix 2 or more kinds of molecules, but suspensions tend to separate when left standing and need to be shaken to blend together before using. Emulsions are formed when 2 or more non-mixable substances, like oil and water, are united with the help of a binder or gum-like substance. They are classified as oil and water or water and oil. Ointments are mixtures of organic substances and a medicinal agent, usually found in a semi-solid form. Water is usually not found in this mixture. Soaps are mixtures of fats and oils converted to fatty acids by heat and then purified. Soaps in the cosmetology industry fall into categories of deodorant, beauty, medicated, and antibacterial soaps. Powders are equal mixtures of inorganic and organic substances that do not dissolve in water. They are sifted and mixed until free of coarse, gritty particles. Let's look now at the chemistry of products and procedures for services in the salon. We'll start with shampooing. As a stylist, it's your most frequently performed service, and often the first impression the client has of the salon and you. Shampooing should be done as often as necessary to remove all foreign matter, including dirt, sebum, which is the scalp's natural oil, styling products, and skin debris. Improper or irregular cleansing creates a breeding place for disease-causing bacteria. This can lead to scalp disorders and even hair loss. Most shampoos are water-based and contain a cleansing agent known as a surfactant. Surfactants are designed to remove oil from the hair. The surfactant molecule has 2 parts, a water-loving part, hydrophilic, and an oil-loving part, lipophilic. During shampooing, the water-loving part is attracted to water and the oil-loving part to oil on the hair. This action causes the oil to roll up into droplets which are lifted into the water and washed away. Water plays an important part in any shampoo. Water is classified as hard and soft depending on its mineral content. Soft water is preferred for shampooing as it allows the product to lather more freely. Refer to your textbook for a list of shampoo types.
It's your job as a stylist to know how to use conditioning products to strengthen hair, add body, and protect it from further damage caused by thermal styling tools, chemicals, and the environment.
Rinses mostly affect the surface of the hair by helping to close the cuticle and make hair feel soft and manageable. Getting hair into better shape is the job of conditioners. Conditioners are used on hair that is rough, dry, and damaged by strong alkaline shampoos, chemical damage, or heat styling. Conditioners generally penetrate deep into the hair. Refer to your textbook for a listing of rinses and conditioners.
Perms and chemical relaxers are covered in detail in Unit 2. However, in this chapter we will focus on the chemical ingredients used to perform these services. Let's start with perms.
Perms allow stylists to chemically reform hair into wavy or curly formations. It starts by wrapping the client's hair around perm tools that are chosen to reflect the desired curl pattern. Next, a perm solution or waving lotion is applied. This breaks the disulfide bonds. It softens the protein structure and allows the protein chains to assume the shape of the perm tool. The hair is then rinsed to remove the processing lotion. Finally, a neutralizer or rebonding lotion is applied and rinsed. The chemical change caused by this product holds the hair in its new position. There are 2 main categories of perms: alkaline waves and acid waves. Alkaline waves are processed without heat and have a pH of approximately 8.0 to 9.5. The main chemical ingredient in alkaline waves is thioglycolic acid or its derivatives and ammonium hydroxide. Acid waves, which are sometimes called heat waves, are generally processed with heat and are usually wrapped with tension. They have an approximate pH of 6.9 to 7.2, and their main chemical ingredient is glyceryl monothioglycolate. The main ingredient in most neutralizers, or bonding lotions, is either hydrogen peroxide, sodium perborate, or sodium bromate.
Relaxers change the molecular structure of hair to reduce excessively curly or wavy hair, quite the opposite effect of a perm.
A relaxer is usually formulated with a heavy cream base. It's applied to the hair and holds it in a straight position during processing. In addition, a smoothing or pressing action is applied to the softened hair, causing the entire protein structure to relax to a straighter position. A neutralizing shampoo reduces swelling caused by alkaline formulas and reforms the disulfide bonds to hold the hair in its new straight configuration. There are two popular relaxer types in use today, a sodium hydroxide type and an ammonium thioglycolate type. When chemically relaxing hair with sodium hydroxide, the disulfide bonds are broken at a point X between the first sulfur atom and the adjacent carbon atom. Thioglycolate breaks the disulfide bond at point Y between the two sulfur atoms. It is important to remember that the chemical action of sodium hydroxide on the hair is irreversible, which means that once you remove the curl from the hair, you cannot chemically recurl the hair. The hair must grow out before additional chemical services can be performed. And remember, sodium hydroxide and ammonium thioglycolate are not compatible. Hair that has been relaxed with sodium hydroxide should never be relaxed with ammonium thioglycolate, or vice versa. Always read manufacturer's directions for specific instructions. Curl reformation is another chemical service performed in the salon. This chemical process combines a relaxer and a perm. With this service, overly curly hair texture is first relaxed. It is then permed to produce a soft curl pattern. The hair is first relaxed with the thioglycolic product, which is smoothed and straightened with a comb or fingers. When the hair has achieved a straightened shape, the thioglycolic product is rinsed. A curl booster and perm rods are used to achieve the new curl formation. The hair is then rinsed again, and a neutralizing or bonding lotion is applied to reform or fix the curl into a lasting shape. This process demands extreme care, since the dual chemical services and the extended processing time can damage the hair. Again, always read and follow manufacturer's directions closely.
Hair color, isn't it great? Manufacturers give stylists an array of colors and lighteners to choose from to create some dazzling hair color effects. Hair color products fall into these general categories: non-oxidative, oxidative, lighteners, developers, and vegetable, metallic, and compound dyes. Let's start with non-oxidative colors.
Non-oxidative colors can be temporary or semi-permanent. Temporary colors are non-reactive direct dyes that only coat the surface of the hair shaft. They last only until the next shampoo, while semi-permanent colors last through several shampoos. Semi-permanent colors are able to penetrate the cuticle layer of the hair versus coating the hair shaft, as with temporary colors. Oxidants, often called developers, are products that have the ability to release oxygen, which is needed for a chemical change. Oxidative colors are mixed with an oxidant, such as hydrogen peroxide, which are available in several strengths. Long-lasting semi-permanent colors, sometimes called demi-permanent or oxidative without ammonia, are mixed with low-volume oxidizers to develop the color molecules and aid in the color depositing. These products do not lighten the hair since they do not contain ammonia. Permanent hair colors, sometimes called oxidative with ammonia, use an oxidation system that starts out with colorless molecules. When these molecules are combined with peroxide, a chemical reaction occurs, building colored molecules. These small molecules enter the hair shaft and penetrate the cortex, where they link together and become permanent. Permanent hair colors can lighten the hair's natural color and deposit artificial color.
Lightening, also called bleaching or decolorizing, is one of the oldest hair color services. Lightness involves oxidation of the natural melanin in the hair.
Lighteners or bleaches are made up of a combination of ingredients, including an alkaline substance such as ammonia. They must be mixed with a developer immediately before application to ensure the oxidation process will be at full strength, as the solution weakens quickly. There are two types of lighteners, on the scalp and off the scalp. On the scalp lighteners are gentle enough to be applied directly on the scalp. They come in two forms, oil lighteners and cream lighteners. Off the scalp lighteners are powder bleaches that contain alkaline salts and a strong oxidizing agent. When mixed with a developer, they are much stronger than oil or cream lighteners and lighten the hair faster. Hydrogen peroxide is the most common developer or oxidizing agent used in hair coloring and in hair lightening. It is used in various proportions and strengths, the most common of which is a 20-volume or 6% solution. Grouped in our last hair color product category and considered to be a less professional category are vegetable, metallic, and compound dyes. Henna and chamomile are examples of vegetable dyes and are some of the oldest. It's smart to know and understand the ingredients in the products you use. The best place to find the information you're looking for is on the material safety data sheets, which are available from product manufacturers. And read the product labels. All the ingredients are listed in their order of concentration. At present, there are over 5,000 different ingredients used by the cosmetic industry. Your textbook lists many of the more common ingredients and their usual function. Be sure to become familiar with them. As a professional cosmetologist, you need to understand the pH of the chemicals you will use on hair, skin, and nails in order to keep them in optimum condition. Several products, such as nitrazine paper, pH pencil, and pH meter, are used to measure the pH in products. Refer to your textbook for a list of salon products and their pH.
That wraps up our chapter on the chemistry of cosmetology. Your clients will never be aware of the effort and time it took for you to understand and apply chemistry to your styling services. But that's okay, because their hair will.
Once you've completed this chapter, you will be prepared to meet the following industry standard for entry-level cosmetologists. Safely use a variety of salon products while providing client services.
Refer to your textbook and study guide for more information on the chemistry of cosmetics. You'll also want to read the case scenario in the It's Up to You section at the end of the chapter to prepare you for your future in the salon.